Hello everyone, this is Gayatri Priya, Assistant Professor in the Department of EC of R&D Engineering College. In today's session of analog electronics, we are just going to discuss about the regions of operation of transistor amplifier. Right. So before getting into this, let us see a common emitter configuration. How a transistor is being operated under common emitter configurations. So in this, if you are taking down a NPN transistor, okay, this is going to be the base terminal and this is the emitter terminal and this is the collector terminal. The emitter current will be flowing outwards, whereas the base current and collector current are flowing towards the junction, right? We know that always the base current will be in the order of ampere, and whereas this is going to be in case of milliampere. Okay, this junction voltage is called base emitter junction voltage, and this junction voltage is called collector emitter junction voltage. This voltmeter will help to read out these two junction voltages, and this is called a rheostat. Okay, so by varying this power supply, okay, we are just going to vary the input resistance. If the input resistance is varies, obviously we are adjusting the input current as well as the input junction voltage. At the time, we are just going to measure what about the variations at the output, so that to capture the input characteristics of common emitter transistor. Similarly, I am going to keep this VBB as constant and I am going to keep this VCC as a variable. So accordingly, this rheostat will be varying, making a change in this collector current and this collector emitter junction voltage. We will be finding out what impacts it makes in the input. Okay, that will depict our output characteristics. Right? As I told you already, the input VB is taken along the x-axis and the input current along the y-axis by keeping your collector emitter junction voltage as constant. Okay, so if we keep this voltage, what happens? We know that, okay, it will act as a simple a diode, a forward bias diode. So once the cut-in voltage is reached, okay, the diode automatically starts to conduct. But if we look at the graph, we could see the curve is growing outward if I am changing down or if I am increasing the output junction voltage. Okay, so this we are here just taking down the slope. Okay, that is finding out the variation of VB and the variation of IB in order to capture what is the actual input resistance going on here. And this is the output characteristics. The output parameter VC is taken along x-axis and IC is taken along y-axis by keeping the base current as constant. Right from 0 it starts to increase. Okay, so what happens here in the sense, it just gives a increasing current. Okay, that is the current increases initially, but afterwards sometimes it gets such times whatever may be the variation in this VCE, okay, and this IC will depict what about the output resistance or not, right? If we look out this diagram, output characteristics, we could see some differentiation over here, right? What may be the three region of operation of a transistor, right? Active region, cutoff region, and saturation region, right? What is the active region? If I make, right, both the input junction as well as the output junction, okay, if the input junction is being forward bias and the output junction is kept at reverse bias, this is called active region. Saturation in the sense, if we keep both the input as well as the output junction as forward bias. Quite opposite to that, if we keep both the input and output junction as reverse bias, this forms a cutoff region. So cutoff in the sense, obviously what happens in the sense, the transistor will not going to be conducting, right? So if we consider, if I am giving a positive voltage to this N type in the sense, this is going to be a reverse bias voltage and this is going to be a reverse bias voltage. So in the reverse bias, the PN junction diode yields 0 output. There will not be no conduction at all. Even if there is conduction, that is going to be very minute in nature. Whereas, if we look at this active region, Okay, the input junction is power bias, the output junction is reverse bias. So what happens in the sense, since these two are negative, the electron will be having a tendency to move towards this p-type material. And similarly, this is n-type material and this is positive terminal. The electrons present in the collector will be get attracted towards this positive polarity. So what happens in the sense here, our electrons present in the emitter will also get a tendency to get attracted towards this positive polarity, thereby making some movements. Whereas if I consider in both the case, what happens? This is n-type, this is also negative. So there will be repulsion. So repulsion comes in the sense automatically what happens here in the sense the electron will be moving towards the p-type material and this electron will also moving towards the p-type material, that way making your p-type material as very thin. At one moment it will be no way, right? So based upon that, here we are having a cutoff region, saturation region and active region, right? The region well below that IB equal to 0 is called the cutoff region, and here we are getting a slanting line. Okay, so a steep line. The left to that region is called as the saturation region, and the intermediate region is called the active region, right? Here you could see a pictorial diagram. Okay, here the water pipe is turned off. That is, there is no flow of water. Okay, here what happens here, we are getting a full force on the water tap. The water is coming in the full swing. Okay, we could not turn it off. This is called saturation region. If you are having a control over this pipe knob, okay, so that I can adjust on or off, this will be referred as the active region. Okay, so this diagram will depict how a cutoff region, active region and saturation region will be occurring. And these are the current relationships present in the regions. Okay, so already we have told in case of a common base configuration, the current gain, that is the current amplification factor is alpha. In case of common emitter, it is beta, and in case of common collector, it is going to be gamma. Right? Hope you understand this session. Thanks a lot.